Now let's talk about input parameters. At the beginning of this chapter, we saw that a function can take input parameter. Before we delve into all possible type parameters, let's make sure you have a clear understanding of what's passing a parameter to a function means. There are three key points to keep in mind. First, argument passing is nothing more than assigning an object to a local variable name. Next, assigning an object to an argument name inside a function doesn't affect the caller. And finally, changing a mutable object argument in a function affects the caller. So let's take the first point, okay? I want to create a new file called key points dot argument dot passing dot pi. Okay, I want to say x equal 3. Now def function funct y print y. Okay, just execute it, func with x. Okay, let's check what it returns. Okay, pi chapter 4 key. I will see that it is printing 3 because it's just receiving the 3 value and as a parameter, and then it's printing in the body of that function. So let's see another point. So it's assigned to arguments names doesn't affect the caller. Okay, so key points dot assignment dot pi. Here I want to say the same, x equal 3 def funct what, in this case you can say x, y, whatever, and x equals to 7. Okay, inside, and I want to execute this func with x value, and then I want to print the x value. Okay, I want to say assignment. Okay, assignment. I will see that it's printing 3. Why? Because in the preceding code, when the x equal 3 line is executed, within the local scope of the functions, the name x is pointed to an integer with a value of 3, leaving the global x unaltered. And finally, changing a mutable affects the caller. For this, I want to create another file also, name key dot points dot mutable dot pi. Okay, in this case I want to define a list 1 through 3. Then I want to define a function. I want to say x index 1 will be equal to, I don't know, 42. As you can expect here, this affects the color. Okay, I wanna execute that function here. I wanna print x here and just see what it happens. In this case with mutable. Okay, mutable like this. And you can see that the original list was what was affected. Okay, all of this happened inside this function, inside this scope function, when the index 1 was changing to 42. Okay, the value of that position was changing to 42 value. How to specify input parameters? There are 5 different ways to specify input parameters. There are positional arguments, keyword arguments, variable positional arguments, variable keyword arguments, keyword only arguments. Let's look at them one by one. For positional arguments, I created this file argument positional.py. I want to define a new function called func, and then I want to say A, B, and C colon. You're going to print them as you can see here, B and C. Then func, I'm going to pass 1, 2, 3. Okay, I'm gonna execute it. Okay, so pi chapter 4 arguments positional, like this. Okay, so positional arguments are read from left to right, and then are the most common type of arguments. Okay, so now let's talk about arguments, keyword arguments, and default value. So just define a new. I create a new file called argument.keyword.py. I want to define another function, func. In this case, A, B, C. I want to print them A, B, C. Then I want to say func equal to A equal to 1, like this, equal to 1, B equal to 2, 3 equal to B equal to 3. Okay, and it will print something like this. Okay, arguments dot keyword, this. So there is a mistake here. It's C. Okay, and it's a keyword argument repeated because there are 2 bits. Okay, let's try again, and now you will see 1, 2, 3. Okay, you wanna change these values. You can change these values, and you will see the difference. In addition to this, the counterpart of keyword arguments on the definition side is default values. The syntax is the same, name equal to value, and allows us to not have to provide argument if we are happy with the given default. For example, we can say I don't wanna print C, I wanna assign C, I wanna say C will have the 1 int value, object value, and I wanna execute it again, and you will see that nothing's changed. Something important you have to know is that you cannot specify a default argument on the left of a positional one. For this, you can say, for example, like this: A, B, C equal to 1. I want to say equal to 3, and then you want to assign 42 to A. Let's check it. Okay, you also position argument follows keyword argument. Okay, this is a common mistake, so let's go back. Nice. In order to create a new, in order to see the next point, which is variable positional arguments, I created this file called arguments.variable.positional.py, where I'm gonna define a new function called minimum, and then I wanna define a parameter like this. If n, or you can put it without parentheses like this, mn equals to n position 0, and for value in n position 1, then if value in is shorter than mn equal to value. Okay, then m4 gonna print mn. Something wrong here is missing a column here. Okay, I'm saying I'm gonna iterate from position as 1, and then if you are more curious, you can print it something like this. Print type n like this, in order to see what is happening inside, which type of value is n. Then I'm gonna execute it. Minimum. I'm gonna say 1 3 minus 7 9 9. Okay. Then I will execute it. Argument variable position like this. As you can see here, when we specify a parameter preceding with an asterisk to its name, we are telling Python that that parameter will be collected a variable number of positional arguments according to how the function is called. And you can see that the type of this value is a tuple. Okay, we are assigning the first value to mn, and then we are iterating from the position 1, okay, to the end. If the iterating value is shorter than the actual minimum, so it will replace it with a new value. Okay, that's the reason we are seeing here -7. If you wanna do something interesting, you can say value is equal to something like this. Okay, you can pass it like this, values, then execute it, and you got the same. Okay, what we're doing here is that we are unpacking this tuple, such as parameters, and we are it will be interpreted by like this, like we did it before. Okay, it's nice. Now let's talk about variable keyword arguments. This one, variable keyword arguments are very similar to variable positional arguments. The only difference is the syntax. Instead of asterisk, double asterisk, we will use double asterisk instead of a single asterisk. Okay, and that they are collected in a dictionary. Collection and unpacking work in the same way. So let's look at an example. I create a new file called argument.variable.keyword.py. I'm gonna create a new function called func double asterisk, as I told you, keywords. Okay, I wanna print keywords. Okay, and then we wanna try with some different invocation like func equal to a equal 1, b equal 2. You can say also asterisk a 1, b 2, or finally func asterisk a1 b2. Okay, like this. Let's check what is the output. No. Like this. Argument variable keyword. Okay, there's something wrong here because it's not a point, it's a comma. Yeah, and you will see it's printing every single execution. It returns the same value. That returns the same. Value. Okay. Well, all the calls are equivalent. In the preceding example, you can see the adding a double asterisk in the line 1 in front of the parameter name in the function definition, which tells Python to use that name to collect a variable number of keyword parameters. On the other hand, when we call the function, we can either pass a key equal to value or name equal to value arguments explicitly, like in the line 4, or unpack a dictionary using double asterisk syntax. Okay, and like in the line 6. In addition to this, you can say something like print keywords dot get. Just gonna print the a value. Okay, I'm sorry, what is this keyword? Okay, yeah, okay. Then I will see it's printing 1, which is the value of a. Okay,